A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. Now, we are familiar with transformers and its working. Transformers work using the principle of mutual induction. What was mutual induction? Yes. When the strength or direction of current in one coil changes, the magnetic flux around it changes, and as a result, an EMF is induced in the secondary coil. That phenomenon is called mutual induction. Here, we can see a 6-volt bulb and a transformer which gives 6-volt output and a solenoid. This solenoid is wound over a plastic pipe. One thing you should keep in mind, this plastic pipe has no role in the working of the solenoid. It only gives the mechanical support to the solenoid. Let's do the experiment. When the switch is on, current flows through the wire AB and the bulb glows. Now, let's remove the part AB from the circuit. Then, the circuit is open and the bulb does not glow. Now, we are connecting A to P and Q to B, thereby completing the circuit. Now, the current is passing through the solenoid. Here, we can see that the intensity of the bulb decreased. What may be the reason behind this? Why did the intensity of the bulb decrease? Let's connect AB again for a better understanding. When current flows through AB, the bulb glows with maximum intensity. But if AB is removed, the current flows through the solenoid, which results in the lowering of intensity of the bulb. Here, the current flows from the transformer to P, to the solenoid, to Q, and to the bulb and back to the transformer. When AB was used, the intensity of the bulb was maximum. But when it connected to the solenoid, the intensity reduces. How does the solenoid reduce the intensity of the bulb? We can say that some changes has occurred inside the solenoid. Since AC is passing, the direction changes 100 times in a second. When AC passes through the solenoid, it acts as an electromagnet. The polarity of this magnet also changes 100 times in a second. As a result, the direction of magnetic field lines are changing 100 times in a second. So, the solenoid experiences a change in flux and hence an EMF is induced. The induced EMF is opposite to that of the applied EMF. This EMF is called a back EMF. So, the resultant EMF of the circuit decreases and hence the intensity of the bulb decreases. Have you ever heard of the core of a solenoid? Core is the inside space in a solenoid. Now, the core of the solenoid is filled with air. So, it is an air core solenoid. Let's insert a soft iron inside the solenoid as core. It may appears as steel rods, but by heating and cooling repeatedly, these rods are made almost equivalent to the soft iron. When the soft iron is inserted inside the solenoid as the core, the intensity of the bulb decreases again. Why is it happening? Here, both solenoid and the soft iron acts as magnets. As a result, the number of magnetic field lines around the solenoid increases. The change in flux increases. More EMF is induced in the coil. So, the effective EMF reduces and hence the intensity of the bulb decreases. The process is called self-induction and the device we used here is called inductor. Inductor is a device which works on the principle of self-induction. Inductors are insulated wire wound into a circular coil, simply solenoid through which AC is passing. Inductors are used to oppose the changes in electric current in a circuit. They are used to reduce the current in a circuit to the desired value without the loss of power. What will happen if we give DC supply instead of AC supply? Let's see. The circuit is now connected to a battery that is a DC source. Bulb glows well when the circuit is switched on. Now, insert a solenoid as in the previous experiment. What do you observe? Yes, there is no change in the intensity of the bulb. Why is it happening? Let's recall one small concept about DC. In DC circuits, the magnitude and the direction of current will not change with time. So, the magnetic flux induced around the solenoid cannot vary. That is, the induced flux is a stationary one. So, there is no back EMF, no decrease in the intensity of the bulb. In short, there is no self-induction happening. If we insert a soft iron rod into the solenoid also, there will not be any reduction in the intensity of the light. So, what do we understand from these experiments? Self-induction is happening only in AC circuits. Since the magnitude and direction of DC won't change with time, the magnetic flux related to it will be remains constant. That's why we cannot observe self-induction in DC circuits. As we discussed earlier, inductors are used to reduce the current in a circuit to a desired value without the loss of power. But the main drawback of inductor is that it cannot be used in DC circuits since there is no self-induction in DC circuits. One point we should keep in mind. Like inductors, resistors can also be used to reduce the current in a circuit. But the resistor will cause an energy loss in the circuit in the form of heat. That is the main drawback of resistors. In this session, we studied about inductors, self-induction and different ways to reduce current in a circuit.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ ENCLAPS the Learning App.